Good day, ladies and gentlemen, and welcome to your Broadband Mapping Initiative Pilot Results Overview webcast. If you would like to ask a question at any time, please type it into the Q&A section of the webcast, and it will be addressed following the presentation. There are materials available to download, including the PDF. This webcast is being recorded and will be available for replay in approximately 24 hours. At this time, it is my pleasure to turn the floor over to Lynn Folan. Ma'am, the floor is yours.
Thank you very much. As Christy said, my name is Lynn Folan, Vice President of Policy and Advocacy here at USTelecom. I am joined here by Mike Saperstein, VP Policy and Advocacy at USTelecom, and Jim Stegman, President and CEO of CostQuest Associates. We are here today to present the results of our Broadband Mapping Initiative pilot project. We'd like to thank our initiative partners, joined by our associations Inititiate and WISPA, and some companies, AT&T, CenturyLink, Chariton Valley, Consolidated, Frontier, River Street, TDS, Verizon, and Windstream. So just a little bit of background on our pilot project. We worked on this project as a result of challenges in broadband availability data that have been challenges for some time. The Commission began a proceeding a few years ago acknowledging that collection of broadband data availability has moved from zip codes to census blocks, but there was now a need to get much more granular. While some might try to politicize this issue, this is a bipartisan issue. It is something that is very important to capture, not just for the providers, but for consumers and policymakers. This was a problem in search of a solution. Our group worked on our effort that we call the Broadband Serviceable Location Fabric. We kicked off our pilot project on March 21st, 2019, and we opted to do a two-state test in Missouri and Virginia. We chose these two states because they're a nice mix of urban and rural areas and had a variety of service providers across the two states. I'm going to now turn it over to Jim Stegman, who's going to walk you through some key findings in our pilot project.
Thank you, Lynn. This is Jim Stegman. I'm going to first walk you through, if you've not heard of or are aware of what the fabric is and what we've tried to do here, is walk you through kind of the background of the creation of the fabric. In trying to create this fabric, we reviewed multiple sources out in the public venue, both in open source and proprietary, to trying to identify a data set that would identify the location of every structure in the country, and specifically in the two states of Missouri and Virginia. We were not able to find a single data set that could do it, but what we were able to discover is that if we combined specific data sets, we could get to a data set that could help us identify and create this locational fabric data set that we'll be talking through. So for that data set, we first obtained parcel boundaries. Those parcel boundaries help us understand the extent of processing, help us understand the collection of buildings on that parcel, help us understand what the information about that parcel means. The second data set that we use is the assessor data sets. Those assessor data sets help us understand the use of that parcel. It may tell us it's a residential, it may tell us it's a business, it may tell us it's a multi-unit development. That information helps us understand what we do with the kind of the final data set that is important to the fabric creation, which is building polygon data set. And this building polygon data set really didn't become available until the last year or so. And what that building polygon data set provides is for the full country of about 170 million polygons or building shapes that can now be used in database processing to help in identification of the location fabric. And if you think about the building polygons, broadband service from a terrestrial provider is delivered to a structure. So now with this building data set, we have the full census of potential structures that could be built to. What we have to do now is declutter that database to identify the broadband serviceable locations. And that's where the parcel boundary really helps us identify that collection of buildings Think of your home. You may have a garage. You may have a shed out back. There may be 3 polygons on your parcel. We need to identify that home where the broadband service delivery would be delivered to, and that's really what the process works through. So as we collect this data, we have put together logic and scoring routines, some statistical models to help us take the disparate data from these multiple vendors and combine it together into something that is useful. However, when we do that, we still have some parcels in which the data collide or they don't make sense. It may say it's a vacant parcel, but we see a building polygon on it. For those things that we just have uncertainty about, we send that out to a managed visual verification process. We have a managed crowd. That managed crowd reviews the imagery. They tell us if that is a broadband serviceable location in the parcel, and they'll actually help us pinpoint where that location is. With that information, we combine it with what we are certain about from the data to create a very good and complete fabric product that we will present today. And I'm happy to say that it's been a success. We released the data set and the report today, and what I'm going to walk you through are just some of the high-level results, and then I'll walk you through a bit of the detail that sits behind that. So on the slide that you're seeing, let me walk you through the 4 major points on this slide. In the upper left portion, you'll see the number 38%. You'll see 445,000. Let me explain what that means. So in this pilot project, we had the participating carriers provide information to us. The information provided was the address and latitude and longitude of the addresses that they would file in a 477 process as served locations. We took those, we identified the census blocks that those fell into, and from that we got the collection of census blocks to analyze. With that in place, we then looked for the fabric locations that weren't linked to an address from the provider. That gave us that first snapshot of what are the unserved locations identified by the providers who participated in the study. And that number is 38% in the rural census blocks of Virginia and Missouri, or 445,000 buildings and homes. But it's important to recognize that this is the upper bound on the issue. We did not have participation from the cable providers. So as such, that 38% is at the upper range, but we did do an analysis to assume that if the cable providers reported all the blocks that they have in the 477 today as fully served, that number would still be well above 200,000. So we now have the bounds about what the issue may be in these 2 states. If you look now at the second pie chart on the left-hand side, where you see the 48%, what we also did is we tried to test how location counts have changed over time. We looked at the 2011 census counts in a census block along with the business counts of 2012. We identified for that the common buildings and came up with the building count within each census block. We then compared that to the fabric counts that we observed today. And as expected, over time, given we are moving 8 years beyond the current estimates of location counts, things would change, and we identified that 48% of the census blocks do have a change in the counts of building structures in the block. And we'll go through that in a little bit more detail. On the right side, we look at distance differences. Today, many carriers use, and actually many parties use geocoding engines that will take an address and interpolate that address to a latitude and longitude on the Earth's surface. Those geocoding engines work well in urban parts of the country and most suburban parts, but they start to fall apart in rural parts of America because the data behind the tools is lacking. And that's really what this fabric is about, is to fill in that rural part of America and understanding where those locations are. So as we looked at the carrier-provided data, they gave us latitude and longitude that were developed from their geocoding tools that they use internally. We compared those latitude and longitudes that they gave to us to the latitude and longitude of the identified broadband serviceable location that we identified associated with that address. And what we found was that 61% of the geolocations were not in the correct structure location. And when we say that, we're looking at a measurement of about 7.6 meters, which is about 25 feet, which is a measurement of kind of accuracy that is used by USAC in the hub reporting system to measure and gauge data. So we looked at that as kind of a key metric to test against. We also found that 25% of the locations from the carriers with their latitude and longitudes were off by more than 100 meters. And what the natural reaction to this is it doesn't seem like a big distance. And we'll show you some diagrams, or there are some diagrams in the report that actually show there are actually a number of locations that are off by more than 1,000 meters. And why does this distance matter? Well, there's two parts to it. And the first part is what you see on the bottom right, which is the pie chart. When you use the geocoded location, you then try and identify the census block that location resides within. As you do that, you then can report that, potentially in your 477 reports. You can use it for other reporting mechanisms, or you can use it to come up with counts. What we found was 23% of the time, the census block identified with the geocoded latitude and longitude was different from what we have in the fabric. So it does show that distance matters. The other thing that distance matters in is as carriers and participants in upcoming auctions may look, they need accurate information to understand the full cost of actually serving an area. And when your measurement is off by 100 meters, that can lead to significant cost accumulation across a broad swatch of territory you may be bidding on. So now let me move to kind of really what the point behind the creation of the fabric is, and that is to help understand the unserved locations in the country. So in this first diagram, we've identified 10 census blocks in Missouri that wouldn't be identified as served in today's 477 process. That is, there is at least a single location in the census block identified by the carrier as being served, and as such, that census block is now reported as served. But the question is, are there unserved locations under those blocks? And if so, how do we get to and observe that? So the FCC has identified this as an issue and has asked for carriers to move to a reporting that is below the census block. And that first step below the census block is polygons. Polygons are just a shape that identifies that service part of a footprint that you provide broadband service within. What we show on this map is our interpretation or our development of a polygon. There's no standard definition yet of what a polygon is. Our approach here was we looked at the geocoded location of the carrier. We identified the road segment that point fell on. We then connected those road segments together and created a 150-foot buffer about that road to create the polygons that you see on the map. They're the light blue. And you can see the extent of that coverage is quite different from what we saw on the previous map when we showed the full blocks as served. So moving to polygons is a benefit to understanding what is served, but it doesn't necessarily help us understand the extent of what is unserved. So on this next slide, what we show, and it may not be readily apparent, but there are little green dots on the map. The issue that we want to clarify here is the quality of the polygons is significantly dependent upon the quality of the underlying data. So when we created those polygons, we used the latitude and longitude that the carrier provided to us for these 10 census blocks. That latitude and longitude was created from a geocoding engine. And as I mentioned, geocoding engines tend to have some issues in rural parts of the country. When we look at the actual fabric locations for the addresses that were used to create those polygons, you can see the fabric locations are somewhat removed from the polygon shapes. So those polygon shapes that were created are uninformed and incorrect because they're based upon bad data. So it's important as polygons are created that they be based upon good information to help the policymakers and public understand what is served and unserved. Now, the exciting thing is that with the fabric, while the polygons help us understand what is served, the fabric helps us understand what is unserved. So in this last image that you're seeing here, we show those 10 census blocks. The green dots are what we consider served or are reported by the carriers. The red dots are those addresses and locations not reported or unserved in this instance. You can see this is a fairly extensive issue in the eastern part. There are a lot of red dots without any green dots out there, but in the current filing process, those census blocks were identified as served. So we're now able to identify what people have called the one served, all served issue and actually interrogate the data below the census block level. So whether polygons are used or addresses are used, the fabric helps reveal the locations of the unserved homes and businesses in the country. So as we develop this over the last, we've actually been working on this for the last 8 months. We've dealt with a lot of data. We've dealt with a lot of inconsistencies. And what we found is there needs to be some criteria set forth that helps in the determination of what a broadband serviceable location point is. And that is, one, the FCC should define what that represents. Is it the farmer's house? Is it the barn on the property? Is it the chicken coop? What defines a broadband serviceable location? That clarity is needed to help identify what locations need broadband and potential funding in the future. We also need to understand the units in those buildings. For example, an apartment building may have 5 or 10 units. Is it important to understand each of the 10 units and the coverage to the 10 units, or is it important to understand the coverage to the building itself? And that question needs to be answered. We also would seek that the assessors in the country try to improve their data over time so that we get good land use. That land use helps us interpret the buildings on the land. If it says residential, we know we may have to look for multiple buildings or a single building, but if it says condominium, we may know that we have to look for multiple buildings. So that land use is critical, but we can overcome that with other techniques that we've built into the data process. So now let's talk about the national fabric. We've completed two states. We've completed it successfully. We've shown the benefits of why the fabric needs to be developed. What will it take to create this national fabric? If we're able to use proprietary data, which is a question out in the NPRM from the FCC, and that proprietary data, while being viewable by the public, so the maps can be produced and people can see these fabric locations, if it can be restricted and used such that the data sets can't be downloaded in full, and that there is some protection given to the rights of the third-party data vendors that we're using, we can create that data set with a budget of about $8.5 to $11 million to create that. And that includes not only the licensing for the data, but also what I referred to earlier as the visual verification process. So that visual verification process sends records out to the crowd. They're reviewed, that information is pulled back in. Based upon the pilot study, it ran about 25 cents a record, but that 25 cents a record is not a single view. It can be upwards of 8 views until we get a confidence level that we understand what's on that parcel. That adds to that upfront cost and is part of that $8.5 million. If, however, it's decided that we need to go to an open source, this data has to be publicly available to any party. That cost escalates upwards of $20 to $25 million, and it depends upon if we can get vendors interested in participating or if we have to create much of this data through visual verification. The timeline for this project, if we were to continue from the proof of concept, so if we started tomorrow, we estimate it would take about 12 to 15 months to complete a national product, with many states potentially available before then, with the kind of I don't want to say the problem areas causing the problem, but the problem areas will just take the timeline out to that 12 to 15 months. So this is a doable project in a time frame that is consistent with expectations. And now let me just walk you through some of why the fabric is needed. So we saw it in that the fabric helps us understand the unserved locations in those 10 census blocks that we looked at earlier. What we're seeing here is when you use geocoders, which are the primary source of information that we have available today, those geocoders give us information that may be adequate for certain purposes, but potentially not adequate for the purpose of what we're looking at, which is trying to identify which customers are served and which customers are not. In this picture that you're seeing on the screen here, the black line represents a census block, the white lines represent parcels, the green squares represent fabric locations, and the red dots represent geocoded locations. And what we did is we pulled data from USAC's hub for the census block. And this is not a critique of the hub, of the USAC reporting, the carriers reporting in the system. It's just a demonstration of how geocoded information can create issues and misunderstandings of the information presented. So as you look at this, the 2011 census housing unit counts in this area was 47. The fabric locations is 21. We're unsure of the inconsistency here. It could be that some of these fabric locations have multiple housing units in it that could make up the difference. In the hub, 30 locations were filed, which exceeds the number of fabric locations, which would say potentially it's complete, but yet I think the requirement may be that they have to build out to 47, and the 47 may not exist. The other issue that you have here is if you look at those red dots on the map, those are the reported locations of where the service was provided. And apparent, this is from a geocoding tool, and as you can see, it leads to some confusion as to which locations are served. Are all locations served, or are some of these locations still unserved? So it, again, comes back to geolocation accuracy is critical to understanding the broadband issue in the country. In this next slide, we show a kind of a flip side of what we saw in the prior slide. In this one, we have 380 fabric locations. The 2011 census housing units was 260. So we have 120 additional locations that were identified since 2011. Most likely there was additional building that occurred between those time frames. The question, though, remains is if the carrier that received funding in this block builds out to the 260, is that block fully served, or what happens to the 120 additional locations in that block? On this slide, it's to pinpoint the issues with geolocations in the rural parts of the country. Many times, geocoders will provide a road, a location on the road center line, because they have no information about where that location may be. The alternative is they may place it at the center of the parcel. In this diagram, you see 8 locations. All the geocoded locations, except for one, are on the road center line, which creates a distance differential. In this, it's off by over 521 meters. And what occurs is as you think about that, well, does that matter? And it's, as a provider is thinking about entering the auction, coming up with their business case, they may be missing out on cost. And these are significant costs that may be incurred that they missed, which may actually show that the business case fails once they actually start to build. So it's important to understand where those locations are. On this next slide, we break out what we showed on the key findings. It's just additional information to help. And as you look at this, this is for the state of Missouri. We show the difference in 2011 and 2012 residential and business counts versus the current fabric counts. And the question is, have the counts changed over time? And you can see on this diagram that yes, indeed they have. There are, 48% of the blocks have the same counts, but 52% have different counts. If you look at Virginia, Virginia had 53% of the blocks had a difference, which is important as we try to understand what would need to be built out to in those blocks. On this next slide, what we're looking at now, we're flipping over to kind of what is reported as served in our study. So let me just clarify what we're looking at here. As I stated earlier, the providers in the pilot study gave us their data in the census blocks, and for those census blocks they identified which addresses would be filed as served. We took that collection of census blocks that had 477 addresses in them as kind of the population of blocks that we would look at. And then what we did is we took the carrier addresses, we linked them to the fabric, and identified the linkage and the non-linkage. So in the non-rural census blocks, where non-rural is defined based upon the census definition of non-rural and rural, we had 1.4 million fabric locations in those non-rural blocks. With the carrier address data that we received, 1.3 million carrier fabric locations were linked to that, which left the remainder of 138,560 fabric locations were not reported or would be reported in the carrier's 477 filing process. So they are identified as unserved based upon the carriers that participated in this study. But as I said earlier, this study does not include all carriers, so that is at kind of the upper end of the estimate. But for non-rural areas, it's 9%. On the rural side, it jumps to 36% of the locations in rural census blocks were identified as unserved in our pilot study. On the right side of the chart, what you're seeing is then the distribution of those unserved. And what the axis on that chart show is the first bar is those census blocks that have a difference of between 1 and 25%. The second bar is 25 to 50, third bar 50 to 75, and the last bar 75 to 100%. And what you see there, if you think about the one served, all served issue, what that really is highlighted by are the last bar and potentially the last two bars in this chart, in that last bar, there is some points identified in a census block, but 75 to 100% of the locations in that block were identified as unserved. So again, just highlighting the fact that there is a good proportion of blocks with this one served, all served concept. If we move to Virginia, Virginia has a similar profile. In the non-rural, the unserved count, based upon the providers who participated in the study, is at 12%. In the rural, it jumps to 39%. It is important to note here that in the Missouri data that I showed, that is based upon a proprietary data set run. The Virginia is based upon an open source run. We've run them separately so that we could experiment and understand the benefit of potentially using proprietary data. If we look at the right side of this chart, you also see that profile looks consistent with what we saw in Missouri. That is the one served, all served kind of concept, that 75 to less than 100% of the block being unserved is quite significant, and quite significant in the rural census blocks. In this next slide, we move now to, if you remember from the summary slide that I presented, we move to an investigation of the differences in distances reported from geocoding tools versus what we now have in the fabric. So in this slide, what we're representing is the carriers provided to us geocoded locations with a latitude and longitude based upon their geocoding tool. We compared that location to our fabric and took the straight line distance and measured it to put together this bar chart that you see. As you can see, there are quite a few measurements of between 0 and 1 meter and quite a few between 2 and 7.6 meters. But the majority of the points are off by more than 7.6 meters, with a long tail going out to 1,000 plus meters difference between the two data sets. And this long tail that you see in this chart really helps us understand how the census block reported can be off. If the distance that point is off by 1,000 feet, we're likely in a different census block, which can impact current 477 reporting and can impact interpretations of this data going forward. So it's important to understand that the fabric helps identify good locational data that can lead to good decisions, good polygon formations, and good data to help support decisions about broadband in America. If we now jump to slide 21, we downloaded the hub data for Missouri and did the same exercise as we did with the carrier data. And again, this is simply to show the differential between geocoded location data that is filed versus the fabric data. And again, we're seeing quite a bit of difference over the 7.6 meters with quite a few records, 25,000, over 100 meters off. And again, this can lead to incorrect census block determinations as you review the data. And with that, I'm going to hand it off to Mike Saperstein.
Thanks.
To complete the presentation.
Thanks, Jim. So just to wrap this up, what are the public policy implications of this broadband mapping initiative that Jim's been describing to you today? One, we think this is the pathway to significantly improve broadband reporting. To that end, we commend Chairman Pai for opening the Digital Opportunity Data Collection docket to address exactly these issues. We think what we've shown here today will go a long ways towards answering the bipartisan questions we've had about broadband mapping. And with this comes the ability for targeted broadband funding for multiple programs. The FCC has an open data collection docket, and it also has an ongoing universal service program. But we envision that this unified national broadband map could be done for state programs, for local programs, for other federal programs, and Department of Agriculture. Anyone who wants to target broadband funding to help close the digital divide could take advantage of this improved broadband mapping. And finally, it allows for efficient network design. All providers want to see the gaps so they can design their networks in a manner to effectively serve the gaps so they can close the digital divide. And seeing exactly with pinpoint accuracy where these locations exist will allow a much more efficient design and in turn allow us to close the digital divide faster and more efficiently. So with that, overall, we think that we, as a nation, we have a lot of work to do, but we all agree that maps need to be fixed. Regulators and Congress across the aisle are interested in pursuing the solutions to do so, and we appreciate the opportunity to provide you with these results here today.
Thank you, Mike. So I think now we'll move to question and answer. I've got a few questions here. Let me just answer the one that's sort of a housekeeping question about whether this recording will be available later. And yes, within 24 hours, the recording will be available for rewatch or watch for the first time. I'm going to start now with some more substantive questions. We've got one. Someone asked just real briefly whether we could explain what we mean when we use the word fabric.
Yeah, fabric is just a geographical term that is used in by geographical professionals to explain kind of an underlying data set of GIS points. I'm kind of repeating myself here, but basically the fabric just relates to all the locations within a geographic area. So if you have the state of Missouri, the fabric, the broadband serviceable location fabric is actually all the points in the state at the latitude and longitude to which we believe broadband service would need to be delivered to today or in the future. So basically it's just trying to identify on the Earth's surface a point at which we can deliver service to.
Next question, someone asked whether they can get access to the location data.
We are looking at producing some sample fabric information that we can release for people to review. We have to work with our data vendors because some of this is proprietary data. So we're working through that right now, but we expect to, in the near term, release some of this so that people can inspect and interrogate what this fabric data looks like.
One more question, and it's asking just how underestimated are the number of unserved and underserved? Essentially, what do we think that the problem is here, as far as if we can estimate the unserved and unserved communities?
Yeah, so as we explained earlier, when we looked at what the carriers would report, those carriers today would report census boxes served if they had even just a single address that fell within that census block. When we took the fabric and identified those addresses that the carriers reported as served, we then looked for those addresses that they didn't provide to us. And when we did that, in the census blocks that were identified or would be previously identified as served, we found in rural parts of Missouri and Virginia that 38% of the locations in those census blocks are actually unserved, even though the block would have been filed as served. So this would be in addition to those blocks in the 477 that are not identified as served. So you have your unserved blocks, full blocks, along with this additional count of unserved locations in the served blocks. And that 38% represents kind of the upper bound, as I stated earlier. It doesn't recognize that we've got participation by all carriers, but we believe the issue to be well above or well in the 20% range for the two states of Missouri and Virginia.
Okay, we do have a few more here. How often should the fabric locations be updated, and who will bear the cost if this goes nationwide, or how will the cost be distributed?
I can't really answer the second question. That is really for policymakers to determine if this is a viable project going forward and really required, and then how that funding is made available. But as far as the frequency, I would recommend that it be maintained annually, if not twice a year, to reflect the changes in the structures in the country. We know buildings are built every year, and there are buildings taken down. We need to reflect that. The other thing that occurs is if we can maintain this product going forward, it only gets better. Out the gate, it will be a high confidence that we have most of the locations identified, but we can't be certain. But over time, we can add locations to that as people feed back information into the product, as new building data sets become available, as other data gets improved, it only gets better.
I'd just like to follow up on that with respect to the nationwide map. Our mapping consortium has done this pilot project with the intention that to prove that the concept works and to get the FCC to adopt it nationwide. So we had envisioned that the FCC would bear the cost of building the fabric nationwide. Another question, were locations served by satellite broadband counted in the pilot?
They were not. We only used those that participated in the study, and I think that was in one of the earlier slides that captured most of the participants in the study. And if you look at that, there were no satellite providers or cable providers.
Another question, what are the next steps with the FCC on this approach? I can take that one. So our consortium has gone in and discussed these pilot results with the FCC, and it's our intention to continue to pursue the comment process under the Digital Opportunity Data Collection proceeding and continue our advocacy to ask the FCC to adopt this nationwide and implement it. That's our hope. Let's see if there's any more. Was there no way to estimate how many locations in the pilot were served by cable or other carriers not included in the pilot?
So we did attempt to provide a lower bound. So what we did is we took the census blocks that we used to arrive at the 38%. And for those census blocks that we identified, we took the last FCC 477 filing, and we pulled from that those census blocks that cable companies reported as served. We made the assumption for the lower bound that the cable companies would have, if they had participated in the study, would have identified that they fully served those blocks. And when we did that, it gave us still a count of about above 200,000 still were identified as outside of the cable footprints and unserved by the providers in the study.
We've got a lot of questions here. Maybe two more so we can wrap up.
Yeah. Can we create the fabric if providers do not submit address data?
Yes, the fabric can be created. The fabric is really dependent upon three primary data sources. Actually, there's a fourth one being a public address file. But the three proprietary, or the three data sets are the parcel vendor, the assessor data, and the building footprints. With that, we can create the broadband serviceable location fabric. With the public address data, we can provide that textual linkage so that it can be related to other data sources such as carrier filings, but the carrier filings are not necessarily necessary for that fabric. They do, however, let me just state it, that they can help improve the fabric, because if a carrier has identified that they have provided service to that address at one point in the past, whether any type of service, we can feel confident in the fabric point that we create is a broadband serviceable location.
Another one, why is there a disparity between open source and proprietary costs, and what makes the open source data require more visual verification?
For the open source data, most likely we would have to move to a open source building product. The primary one out there is Microsoft Building Product. The Microsoft Building Product has about 40 to 50 million less building polygons in it than the commercial source. As such, that gap needs to be filled. There's also potential issues that the Microsoft Building Product, we don't know the vintage of the satellite imagery used, so additional quality checks will have to be instituted. So that leads to visual verification. So we anticipate potentially 15 million records may need to be reviewed if we use proprietary source. If we move to public source, that may escalate because we will likely need not only to get more parcels sampled, but we'll also likely have to find some additional address data sets or have those open sourced, which will add to the budget.
I think we can do maybe one more. Can the fabric be leveraged for other purposes such as Next Gen 911?
I believe it can be leveraged for many a purpose. With basically the delivery point of where broadband needs to be delivered is typically where people live and work. And that source should be a valuable source to a multitude of other public and private requirements.
Well, thank you everyone for joining us today. Again, this will be available for watching at another time. Within about 24 hours, there will be a link sent out and available on the USTelecom website to reach this webinar. And thank you for participating.